Assalamualaikum and good morning to Evaluator. The title of my research is Improving Potassium Retention in Acidic Soil by amending Muriate of Potash Fertilizer with zeolite. This is the table of content of my presentation from introduction and literature review till references. For introduction and literature review, potassium is an essential macronutrient for plants that participate in many physiological processes. Potassium is easily lost during the leaching process and very likely to be leached out and therefore run off from the soil system. In addition, the leaching of K fertilizer also occurs in acid soils. Infiltration into the soil results in low replenishment and high K loss, which indicate a general deficiency in densely populated areas. For problem statement, due to low retention capacity of K and high mobility of K in the soil, K is prone to leaching. Thus, farmers tend to apply excess fertilizer to attain higher yield. This approach is not economical. For objective, first, to sample and characterize selected physicochemical properties of soil sample to be used in laboratory leaching of case study. Second, to characterize the selected chemical properties of zeolite. Third, to determine the effect of amending MOP with zeolite at different rates on K retention in soil and selected chemical properties of soil. For materials and method, first and foremost, soil sample and zeolite were characterized for selected physicochemical properties. Next, a leaching study was carried out for 30 days to determine the effect of zeolite in improving K retention in acid soil. During the experiment, leachate sample was collected every 3 days for 30 days. The leachate was analyzed for K. At the end of leaching experiment, soil sample were collected and analyzed for pH, EC, and K. For results and discussion, the table of selected physicochemical properties of soil, the soil sample was a sandy loam, low pH, and low K concentration. For table of selected chemical properties of zeolite, they have a pH neutral, high CEC, and high K concentration. The results of K availability in leachate with different rates of zeolite were obtained. A total of 10 batches of leachate were tested in 30 days as shown in the graph. There was a reducing trend of K content in all treatments over 30 days of leaching. The graph shows the K content range from 5 ppm to 9033 ppm. Starting day 3 of leaching, K loss in T1 soil with MOP only were high compared with other treatments. This indicates the zeolite had high K absorption compared with soil with MOP only, which reduced the K leaching over 30 days of leaching experiment. Apart from that, soil without zeolite T1 had the highest K leaching in day 3 and day 6 compared the treatments with zeolite T2 to T5. This is because soil solution K has a high chance of leaching and thus lost from the soil system. There is low replenish and high loss of K by leaching in acidic soil, especially in the highly weathered soils in the tropics. Besides, the soil with 6 grams of zeolite T5 in days 30 obtained the lowest concentration of K. This might be due to the crystal of zeolite minerals that enable the chelation of K on the crystalline structure of zeolite that improve K retention. The bar chart demonstrates sum of K content of soil after 30 days of leaching. The accumulation of K in leachate was reduced significantly where the rate of zeolite was increased T4 and T5. The result shows that the accumulation of K in leachate significantly decreased in soil with MOP and zeolite T2, T3, T4, and T5, then in soil with MOP without zeolite T1, and soil alone T0 at 30 days. The lowest concentration of accumulation of K in leachate in T2, T3, T4, and T5 were partly due to increase in the rate of the zeolite as maintained of the nutrient of K in soil. The large surface and crystalline structure of the zeolite were able to reach the positively charged K ions and decrease the K leaching. This observation could be one of the reasons why the T1 was the highest of the other treatment in accumulation of K in leachate due to the presence of soil with MOP without zeolite. The K concentration retained in soil after leaching in different treatments is shown. The treatments with the highest rate of zeolite application T5 were able to retain the higher K concentration in the soil. This was due to high rate of zeolite application had a higher K sorption and surface area. This enabled the absorption and chelation of K on the zeolite more effective. Meanwhile, T1 soil and MOP only had significantly lower K retention because K is naturally mobile in the soil, and the highly weather acidic soil with low clay content reduce the absorption of the K clay surface, prevent the K for leaching. The pH value is soil after 30 days of leaching between different treatments. The treatments of MOP, ML with zeolite T2 to T5 show significantly high soil pH compared to soil only T0. Besides, the increased soil pH was also due to the precipitation of calcium by the zeolite. The higher buffering capacity of the zeolite also explains the increase of soil pH in this treatment with zeolite. Besides, the content of inherent of calcium and magnesium in zeolite might have contributed to the increasing in the soil exchangeable calcium and magnesium content that able to increase the soil pH. This explains the no significant difference in the soil pH between T1 soil and MOP only and treatments with zeolite T2 to T5. The EC in soil after 30 days of leaching. Based on all the treatments, the results shown that the EC in soil after leaching range from 10 to 33. The EC in T3 gave the highest value, which is 33, and the lowest value in T0, which is 10. Therefore, there were significant difference in terms of EC at all treatments. As a conclusion, treatments with zeolite were able to reduce the K leaching from the soil. Application rate of 20 tons per hectare zeolite was found to provide the best retention of K in the soil. The treatments with zeolite application also improved the soil pH to near neutral. They indicate the potential of zeolite application in amending the soil chemical properties. This research is suggested to be carried out in the field with test crops to test the effect of zeolite in retaining the K in the soil in natural environment. This is references of my presentation. That's all from me. Thank you.